Hi everyone, welcome to the intermediate section of the program where we'll be continuing to develop our Python skills. I'm Dion Rikai and I will be your instructor for these few videos. In this first video, we will be looking at various data structures in Python. So what is a data structure? A data structure is a way of storing multiple pieces of data into a single entity. And we have already used one data structure in the program so far, which is the list. And in this video, we'll be looking at a few more of these data structures. So we will first look at the tuple. In Python, a tuple is very similar to a list, but it is used in a very different way than how you would normally use a list. To create a tuple is very similar to a list. You list out the elements in a tuple, but instead of using the regular square brackets, you use the round brackets, also known as the parentheses. So if we run this code, you can see that the tuple, when we print it out, gets printed out just how you would print out a list, but with the round brackets instead of the square brackets. Like a list, we can also index a tuple to get elements at specific positions of the tuple. So indexing at index number 0 will give us the first element of the list. So when we print out index 0, we get the number 5 since it's the first element. We can also do slice indexes. So since we want the elements from index 1 up to index 3 to give us this element and this element, and we can see when we print it out, we get the two of them over here. So just how you would do indexing with a list, you can do the same thing with a tuple. You can also create an empty tuple by just putting empty brackets, and you can see when we print it out, it prints out just like the empty brackets would. Like a list, you can get the length of a tuple, which is the number of elements in the tuple, using the len function. So the length of tuple x is 3 because there are 3 elements, and the length of tuple y is 0 because there are 0 elements. So when we print out the length of these two tuples, we get 3 and 0. And like a list, you can use a for each loop on a tuple, and it will go through each element in the tuple just like it would do so for a list. So in this for loop, we just print out each element in the tuple, and we can see the 3 elements in the tuple get printed out. So far, it seems that list and tuple are nearly identical. So let's look at some of the differences between a list and a tuple. So here we're trying to create a tuple which has one element. And then we print out that tuple and we print out the first element in it. So let's run a program and see what happens. Okay, so when we print out the tuple, we don't get a tuple, we just get the number 5. And when we print out the first element, which should be the number 5, we get an error saying that we can't use indexing on an integer. So what happened is that Python doesn't realize that this is actually a tuple because the regular parentheses, the round brackets, in Python are used to denote order of operations, just like you would in a math expression. So to tell Python that this is actually a tuple, we just put a comma after the first element. Now, if the tuple has multiple elements, this is not necessary because you need to put a comma. But if it's just one element, you need to put a comma to let Python know that this is actually a tuple. So when we run the program this time, we can see that it prints out the tuple, which has one element, and it prints out the first element. So that's just something you need to be aware of. Another thing you need to be aware of with tuples that makes them different from lists is that you cannot modify the data in a tuple. So normally with a list, if I wanted to change the second element to this number, I could do so with this line of code. I could also add a new element to the tuple using the append, to a list rather, using the append, and I could remove the last element from a list using the pop function. However, none of these will work with a tuple because in Python, you're not allowed to modify the data in a tuple. So if I run this code, you can see that it says tuples do not support item assignment. And these other two lines of code would also give you errors. So you cannot modify the elements of a tuple. Since tuples and lists are so similar with the exceptions that we just talked about, why do they exist? Why do both of them exist? Why not just use lists instead of tuples? And the main reason is more about when you should use them. So a list should be used when you have several instances of the same type of data, whereas a tuple should be used when you have several properties of a single entity. So what does that mean? So I would use a list if I wanted to store many names because I have many instances of the same type of data. I have many names of different people. But I would use a tuple if I wanted to store many pieces of data about a single person. For example, the person's first name, last name, age, and email address. I would store that data in a tuple because it's different types of data about a single person. Okay, so let's look at another trick you can do with tuples. This trick is called unpacking. So here we have a tuple which has someone's first name, last name, age, and email address. And we can get those individual pieces of data into their own variables using indexing. So to get the first name, we use index 0, last name index 1, and so on. We can then print out the individual pieces of data. However, there is a faster way to do this, which is called unpacking, which is done in this line of code here. So what this line of code is saying is take the user, which is a tuple, and store the first element of the user tuple into this variable called first name, store the second element of the tuple into the variable L name, store the third element into the variable age, and store the last element into the variable email. So this line of code here does the same thing as these 4 lines of code. So this is a common shortcut which is used with tuples. Now, technically you can do this with a list as well. So if this user was a list instead of a tuple, this line of code would still work. However, unpacking is more commonly used with tuples instead of lists. So I'll just run this code just to make sure everything works. So you can see the first print is from the regular way of using indexing, and the second print is from the shortcut using unpacking. Another way in which tuples are commonly used is to return multiple values from a function. Normally, when you return something from a function, you can only return one variable. An easy way around that is to simply store the 2 things that you want to return, or more than 2 things, into a tuple and then return that entire tuple. So for example, I have this function called first letter, which has a parameter called word, and what it will do is take the first letter of that word, convert it to lowercase, and store it in a variable. Then do the same thing again, but convert it to uppercase and store it in a variable. Now, if I wanted to return both the lowercase and the uppercase, what I can do is store the 2 of them in a tuple and then return that tuple. Now, when I call the function, if the word I give to it as the parameter is the word hello, I can then get the tuple that the function returned, and I can use the unpacking technique that we just learned to get the lowercase and the uppercase, and then I can print out the 2 of them or use them however else I like. So let's just run the code and see if it works. So you can see the lowercase h and the uppercase h are both printed out. Another interesting thing about tuples is that you can put a tuple in a list. You can also put a list in a tuple, and you can put a tuple in a tuple. So you can compose them in any way that you like. So for example, I have this employees list, which contains 2 tuples. The first tuple contains the name Alice and her ID number, which is 1. The second tuple contains the name Bob and his ID number, which is 2. If I print out employees 0, this is the first element of the list. Now the list has 2 elements, which are the 2 tuples. So when I print out employees 0, I'll get the first tuple. When I print out employees 1, I'll get the second tuple. Now, because you can also index the tuples themselves, if I print out employees 0, 0, the first 0 will index the list to give me the first tuple, and then the second 0 will index the tuple to give me the name Alice. If I use 0 and 1 for the indices, the 0 gives me the first tuple, but the 1 gives me the ID number in that tuple. And similarly, this line of code here will give me the name Bob, and this line of code here will give me the ID number 2. So let's just run these so we can see we get the first tuple, then the second tuple, then Alice, then 1, then Bob, then 2. Test out your knowledge of tuples. Here is an exercise for you. Create a function called convert, which has one parameter called meters. And what this function will do is convert the number of meters into the number of feet and the number of inches. So for example, 2 meters is 6 feet 7 inches. So if I call this function with the number 2 for the meters, it should return a tuple with the number 6 and the number 7. 5 meters is 16 feet and 5 inches. So if I call the function with the number 5 for the meters, the function should return a tuple containing the number 16 and the numbers 5. Hopefully you have paused the video and have tried out the tuples question, because now we're moving to the next topic, which is another data structure called the set. So in Python, once again, creating a set is very similar to creating a list or a tuple, except that this time we use curly brackets instead of the round brackets or the square brackets. We can print out a set just like we would print out a list or a tuple. We can also create a set with a single element by just putting that single element in the curly brackets. And we can get the length of a set, which is the number of elements in the set, by using the length function, just like you would for a list or a tuple. And you can use a for loop with a set, and the for loop will go through each element in a set. So here we're just printing out each element in the set. So let me run the code and see what happens. So first we print out the set X, then we print out the set Y, then we print out the length of X and the length of Y, which are 3 and 1. Then we print out each element in set X, which is 8.8, high, and -4. Now, you can modify the elements of a set, but this is not done using append and pop like you would with a list. Instead, you use add and remove. So when you use the add function, you specify what data you want to add to the set. In this case, we're adding the number 7 to set Y. So when we print out set Y, originally set Y was just the number 2. Now it's the number 2 and the number 7. We can also remove an element from a set by specifying which element we want to remove. So in this case, we're saying remove the element 8.8 from set X. So when that is removed, we'll only have the string high and the number -4 left. So when we print out X, we can see that these two elements are left. So once again, just like we did with tuples, let's look at some of the differences between a set and a list, because so far they seem to be similar. Unlike a tuple or a list, you cannot create an empty set by just putting the empty brackets. And when we learn about dictionaries later on in this video, we will see why. So to create an empty set in Python, you have to use the set function. So you just call the set function like this, and this will create an empty set for you. Next up, we have a set called y with these 4 elements. We will print out y, we'll print out the length of y, then we'll add this string to the set y and print it out again. So let's run the code. Okay, so you should see something interesting happen. So this is our set y, but when we print it out, this is what we get. Now, the reason is that in Python and most other programming languages, a set cannot contain duplicates. So we have the number -3 twice, but it only appears once in the set. And that is because the set automatically deletes duplicates for you, or it just ignores them. And so when we print out the length of y, we get just the number 3, because although we listed out 4 elements, it ignores one of them because it's a duplicate. And we can see this again down here when we add the welcome string to the set. Since the string welcome is already in the set, even after we add it to the set and we print out the set, it hasn't changed because it ignores this added string because it's a duplicate of what's already in the set. Another interesting thing about a set is that the order of the elements can change. So here the order was -3, 7.7, and a string, but when we print it out, it's a string, then -3, then 7.7. And that is because with a set, it does not keep the elements in their original order. So if you need the elements to be kept in their original order, you cannot use a set. So just to reinforce that point, here we have a set, the same set, and we want to print out the first element of that set by indexing it. We run the code. Okay, so to reinforce that point, we're going to try to print out the first element of that set using indexing, and let's see what happens. You can see it says the sets are not subscriptable, meaning you cannot use indexing on a set. So the reason is that the set does not keep track of the order of the elements, so you cannot ask for the first element or the element at any particular index. So what is the purpose of a set? Well, because a set automatically ignores duplicates, if we need to keep track of unique elements, we can add those elements to a set, and the set will automatically delete the duplicates for us. So that's one advantage of a set over a list. Another advantage is that to check to see if an element is in a set is very easy, especially in Python. So here we have a set with 3 numbers, and we have a number I, which is 77. To check to see if that number is in the set, we just do if I in X, and that will check to see if the number I is in the set X. And doesn't have to be I and X, you can use any variable here and any variable here, and it will check to see if this element is in this set. Now, of course, the number 77 is in the set, so when we run the program, it will say yes, 77 is in the set. If I were to remove 77 from the set, it will now say no, 77 is not in the set. Now, technically, you can do this type of if statement with a list as well, or even a tuple. So I will just show you that now. So we can see it still works with a list or a tuple. However, it is much faster with a set, especially if you have a large number of elements in the set. It's much faster. The computer will determine if the element is in the set much faster than if you used a list or a tuple. So that's the other main advantage of a set over a list. Like lists and tuples, you can put a set in a list or a tuple. However, you cannot put a list in a set. The reason is that you cannot put something which is modifiable into a set. So because you can modify a list, you cannot put it in a set. You also cannot put a set in a set because a set is modifiable. However, you can put a tuple into a set because tuples are not modifiable. So if I run this program, you can see it says an hashable type list, which basically means we cannot put a list in a set because it is modifiable. Let's try a set in a set. And it gives a similar error. But if we try a tuple in a set, it works fine. Okay, so let's look at a simple program with sets. So we want the user to enter 5 numbers, and we want to tell them how many unique numbers they entered. So we don't want to include any duplicates. So to do this, we first create an empty set. Remember, you have to use the set function to do so. Then we have a for loop which runs 5 times. We tell the user to enter a number. We get that number from the user and convert it to an integer. Then we add that number to the set. Now after the for loop runs, we then print out this message: you entered dash unique numbers. Now, in this message, we're displaying the length of the set. And the reason is that because the set will ignore any duplicates, the length of the set will be the number of unique numbers entered by the user. So let's test out this program. So we'll enter the number 3, then the number 7, then the number 7 again, then the number 3 again, then the number 6. So it says you entered 3 unique numbers, which is correct. We only entered the numbers 3, 7, and 6. So now that you've learned a bit about sets, your challenge is to modify this program so that when the user inputs a number, we tell them whether or not they have already entered that number. So that is your challenge for this topic. You can go ahead and pause the video and try it out, and then we'll move on to the next topic. Come back. The last data structure we'll be covering is the dictionary. So the dictionary is a bit different to the other data structures we have seen so far, and the reason is that the data in a dictionary comes in pairs of keys and values. This is an example of a dictionary. You can see we have one element here, another element here, and a third element here. And each element consists of 2 pieces of data. In this case, a number representing the employee ID and a string representing the employee's name. So with a dictionary, you list out the pairs of data, separate them with commas, and you use the curly brackets just like you would with a set. And for each piece of data, you use a colon to separate the key and the value. So when we print out our dictionary, you can see it's printed out over here. You can get the length of a dictionary, which is the number of elements in it. And like a list, we can use indexing on a dictionary. So the index of a dictionary is not the order of the element. Instead, what it does is it looks for this key in the dictionary. So if when we take employees and index it with the number 2, it will look in the dictionary for the element which has a key of the number 2, which in this case is Charlie. So emp2 will be the name Charlie, which is why when we print it out, we get that name. We can also add elements to the dictionary like this. We specify the key that we want to store the element under in the index brackets, then the equal sign, and then the value that we want to store for that key. So when we print out the employees now, we can see we have a new employee in the dictionary with a key of 3 and a name of Dave. If we want to edit one of the values in the dictionary, we can just reassign the value that we want to the key that we want to change. So if we want to change Bob with an ID of 1 to the name Bart with the ID of 1, we can just say that, can just set key number 1 or index number 1 to the name Bart. And when we print it out, you can see that it has changed from Bob to Bart. I've added some more code to see what's really the difference between a dictionary and a list, because so far it seems that dictionaries work very similarly to lists. So here we've removed an element from the dictionary using the pop function. But unlike a list, when we specify which element we want to remove, it actually just completely removes that element without affecting the others. So what I mean by that is we can see down here that it has completely removed the element with a key of 1, which was Bart. So Bart is no longer in the dictionary at all, and the other elements in the dictionary, their indices did not change. So the reason for that is that the keys of a dictionary don't have to be 0, 1, 2, etc., etc., like they would normally be for a list. The keys of a dictionary can be basically anything with a few exceptions. So to demonstrate that point, I'm going to add an employee to the dictionary, and he will have an ID of 10, and his name will be Ian. So you can see that he got added to the dictionary down here. So in this dictionary, the keys are 0, 2, 3, and 10. So that shows you that the keys of a dictionary don't have to be a specific sequence of numbers. It can be basically anything. And to show that point even further, I'm going to add another employee to the dictionary, but this employee will not have a number for their key. They will have a string for their key. So when we print out the employees now, you can see that most employees still have a number for their key, but Ryan, this new employee, well, newly added to the dictionary, his key is special. It's a string instead of a number. So that shows you that the keys of a dictionary don't have to be numbers. They don't have to be in any specific sequence. They can be strings. They can be arbitrary numbers. So a dictionary in that sense is like an extension of a list, a generalization of a list. I have a different dictionary. This time this dictionary has strings for the keys and numbers for the values. So what this dictionary contains is the grades for various students, and the keys are the names of the students. So if I wanted to get Billy's grades, I would take the grades dictionary and I would index it using Billy's name as the key. And when I print out Billy's grades, it should give me 58. So let's run that and see if it works. So yeah, you can see I get 58. I can also add a new student to the dictionary by assigning that their key, their name as a key, and their score as the value. And I can change a student's grade by a similar assignment. So since Amy is already in the dictionary, when I assign 77 to her key name, it will replace her current score, which is 75, with a new score, which is 77. I can also remove someone from the dictionary using the pop function and specifying the key of that person, which is their name. So here I've removed Keith from the dictionary. So when I print out the new dictionary, you can see down here that all these changes have been made. We've added Zach, who has a score of 62. We've changed Amy's score to 77, and we have removed Keith from the dictionary. A few other things you need to know about dictionaries. You can create an empty dictionary by just placing the curly brackets with nothing inside them. And this is why you couldn't create an empty set with the curly brackets by themselves. It's because Python will think that you're creating an empty dictionary, not an empty set. Also, if you use a for loop on a dictionary, as we have in this case, it will go through the keys of the dictionary. So it will ignore the values, it will only go through the keys. So with this for loop here, I've printed out all the keys of the dictionary. So let's run the code and see if it works. So yeah, you can see the for loop goes through the keys of the dictionary. If you want to go through the values of the dictionary, you can do it like this. So you have to call the .values function on the dictionary in the for loop. So let's run that. So we can see this time it gave us all the values in the dictionary instead of the keys. Now, if you wanted both of them, you can use the .items function instead. And in the loop variable, you need two variables, one to get the keys and one to get the values. So what I've done here, I've stored each key into the name variable, and I've stored each value into the G variable. So for each key and value in the dictionary, I'll print out the key and print out the value. So let's run it. So we can see down here, prints out Amy 77, Billy 58, Zach 62. And of course, with any for loop, you don't have to print out the elements. You can do whatever you want with them, whatever is useful for your program. So as we close off this video on data structures, your final task for your topic on dictionaries is to create a dictionary where the keys are email addresses and the values are passwords for those email addresses. And you need to ask the user to enter their email address and then their password. If their email address and password are correct, you let them know that it's correct. If it's not, you let them know that it's wrong. If you want an additional challenge, you can first check to see if the email address is in the dictionary, and if it's not, you can ask them if they want to add it to the dictionary, in which case you would have to ask them to enter their password to create that account. So good luck with that exercise, and thank you for watching this video, and we will see in the next video.